Today we are doing lesson 1-4 and we're going to expand on what we learned in lesson 1-3. Lesson 1-3 we talked about different types of angles and the angle addition postulate. We also talked about angle bisectors, and today we're going to talk about pairs of angles, special angles that when you put them together have a special relationship. The first type of angles is the adjacent angles. They are two angles in the same plane with a common vertex and a common side, but no common interior points. So if I draw a pair of adjacent angles, I could draw an angle here and call it angle A, B, C. Then I'm going to draw another angle that's attached to it, sharing a side. So I'm going to draw angle A, B, and we'll call this point D. So notice, these two angles have the same vertex, angle B. They have a common side, which is ray BA, but they have no common interior points. I like to think of them as neighboring angles. Over here, an angle DBA, they live inside their house. Over here, an angle ABC, they live inside their house. And then they've got the fence in between them that is shared, that divides their two insides, their two houses. That's adjacent angles. There's a special type of adjacent angles called a linear pair. Notice the word linear has the word line in it. So it will be two angles forming a line. It's a pair of adjacent angles whose non-common sides are opposite rays. So in this picture, I'll draw it as best I can. I have one angle, and then I have another angle whose non-common side, so here's the common side right here, the non-common side actually forms opposite rays with the other non-common side. So notice these two angles together do form a line. So we can call this again angle A, B, C, and we can call this angle D, B, C. They are adjacent, again, because they share a vertex and they share a common ray, but their two non-common rays form a line. So angle ABC and angle DBC form a linear pair because they're both adjacent and they form a line when you put them together. Another pair of angles is complementary angles. These are two angles whose measures have a sum of 90 degrees. So for example, I could have one angle that measures 20 degrees and then another angle that measures 70 degrees. These two angles together are complementary. 70 is the complement of 20, and 20 is the complement of 70. So when we put them together, 70 plus 20, they are complementary because their sum is 90 degrees. Similarly, we have supplementary angles. These are two angles whose measures have a sum of 180 degrees. So for this example, again, if we had an angle that measured 20 degrees, then the supplement would be an angle that is 160 degrees. These two angles add up to 180. 20 is the supplement of 160 degrees. 160 degrees is the supplement of 20 degrees. Together they have a sum of 180, so they are called supplementary angles. The last type of angles that we'll talk about are vertical angles. These are two non-adjacent angles formed by two intersecting lines. I would like to draw your attention again to the complementary and the supplementary angles. Notice it is not necessary for them to have a common side at all. So these do not have to be neighboring angles, they don't have to be adjacent, they don't have to be touching at all. They could be in two completely different diagrams. But if they add up to 90 or add up to 180, then they'd still be considered complementary or supplementary angles. So these vertical angles, they're not adjacent. They're formed by two intersecting lines. So if we draw two intersecting lines, both with 2 arrows since they go on forever in both directions. The vertical angles are the angles that are across from each other. So the angles that I'm marking here, those are considered vertical angles. Also, the angles that I'm marking here in black, this would be another pair of vertical angles. They do share a vertex, they share a point, but notice they don't share a side. These black angles don't share anything but the point in between the two. And these green angles, these green angles don't share anything besides the point in between the two. They don't share any sides at all. So let's go over onto the back side of your note page and we'll do some examples. Back side of your note page looks like not that. Sorry guys, I didn't get it up. Hang on just a second. Here's the back of your examples. Someday I'll get one of these videos right all the way through. So let's use the diagram below to answer these questions. The first question is, what is the common side in this diagram between these two angles? I would like to point out we have angle BAC and we have angle DAC. So the common side between the two would be right here. That common side would be ray AC. What are the opposite rays? The opposite rays, remember, they do have a common endpoint right here at A, and they're going to be the non-common side in this linear pair, because notice this whole angle is forming a line. It would be considered a linear pair. So the two opposite rays in this diagram would be ray AB and ray AD. What are the names of the linear pair of angles? Again, we said that since these two angles form a line, they are a linear pair. One of these angles, we said, is angle BAC, and the other angle on this side is angle DAC. Don't forget that the first angle could be named angle CAB. The second angle could be named angle CAD. However, we could not just use the name angle A in this picture because there are actually 1, 2, 3 angles that could be considered angle A. That's not specific enough. We have to use all 3 points. What appears to be true about the sum of the measures of the linear pair of angles in this diagram? Well, if we know that these angles form a line, they're a linear pair, we know that they're exactly 180 degrees in a straight angle formed by these opposite rays. Let's go on down and look at our examples below. Example 1A says, tell whether the angles are only adjacent, and form a line, a linear pair, or not adjacent at all. This is when it would be really helpful for you to have some colors out. First, we're looking at the pair AEB and angle BED. So I'm going to do angle AEB in blue. Angle AEB would be this angle right here. Angle BED would be all of this angle over here, even including that ray. Well, notice these two angles share a vertex, these two angles share a ray, and these two angles together form a straight line. So the answer here would be that they are adjacent and they form a linear pair. Let's look at angle DEC and angle AEB. I'm going to erase my colors here. Start again. I'll do angle DEC in blue. Angle DEC would be this angle right here. And I'll do angle AEB in red. AEB. These two angles do share a vertex, but they do not share a common side. There's this huge gap in between the two sides of the angles. So if these two angles don't even share a side, then they can't be adjacent. The answer would be not adjacent. If they're not adjacent, then a linear pair isn't even an option at all, because in order for two angles to be a linear pair, they have to first be adjacent. They have to be sharing a side and form a linear pair. So if they don't share a side, then our answer is simply that they are not adjacent. How about example 1b? The first part is angle 7 and angle SPU. Angle 7, remember we can name angles with numbers, is right here. And then angle SPU. SPU is this entire angle right here. I would like you to notice that these two angles do share a vertex. These two angles do in fact share a side, but in order for them to be adjacent, the last point that we need to know is that they can't share any interior points. We have overlapping angles here with the green and the red, which means they do share common interior points. So even though they share a vertex and a common ray, these angles are not adjacent at all because they do share common interior points. How about angle 7 and angle 8? Here's angle 7 and here's angle 8. This looks very similar to the problem that we just did above it. Again, they share a vertex, but they have a big gap in between the two of them, so they don't share a side at all. So if they don't share a side, then they can't be adjacent. This is another example of angles that are not adjacent, which again means that they also can't form a linear pair. At this time, I would like you to find the second part of the video for this lesson and watch part 2 to finish these examples.